Hi, this is our lesson 1.5, Aspire to Do. In this lesson, we're going to determine a quadratic model to describe the given data and use that model to answer some application questions. So first, you have to know what we're talking about when we talk about a model. And in this case, it will be a regression model. A regression model is used to investigate the relationship between two or more variables and estimate the variable based on the others. So what does that mean? It means that if I give you some numbers or some points on a graph, you want to determine whether there's some kind of relationship between those points. All right, so what we're going to do first is we're going to get comfortable with our graphing calculator. And we're getting comfortable with it looking at some linear equations first, and then we're going to move on to quadratic equations. So this data that I'm giving you, we're going to input it into the graphing calculator. So I'm going to stop, and then I'm going to input that in. So you want to make sure that you have that piece of paper around so you can see what I'm doing. Okay, so this calculator is very similar to the one that you use at school. What we're going to do is we're going to put some data into the calculator. Now, the other day when we played with the graphing calculators, you input equations, and you input the equations in here. So that's just giving the calculator an equation, saying, now please graph it. We're going to do something a little different today. We're going to give the calculator some data and say, can you find an equation for me that matches the data? All right, so we're going to get out of here, and we're coming over to where it says stat. Push stat, and we're going to edit, and we're going to put some data in here. Okay, so I've got data in here that's old, so I'm going to go to the top. I'm going to hit that scroll button and go up to list 2, and I'm going to hit clear, enter, and it will clear out that whole list. I'm going up again, up to list 1. I'm going to hit the clear button, and I'm going to hit enter, and that clears out that list. All right, so what we want to do is we want to put in the data that was on that piece of paper. All right. Okay, so I'm going to put all of the X values in first, and they're going into list 1, and all the Y values are going to go into list 2. So my X value first was 3, and I hit enter. And then I'm going to put in -3, and I hit enter. I'm going to put in 2 and enter, and -2 and enter. And now I'm going to hit the arrow key and go into the next list. So the matching Y value for this one was 12, enter. And then we had 2, enter, and 9, enter, and 4, enter. All right, now I want to graph those points. So to graph those points, I'm going to hit the graph button and see what happens. Nothing. I can't see anything. All right, so I need to turn on my stat plots because here I was using the stat key. So I'm going to hit second, stat plot. So I hit the blue button, and then that turned the blue button on. See all it says all my stat plots are off? I'm going to turn the first stat plot on. So I hit enter, and now it's hovering over the on, and if I hit enter, that will turn my stat plots on. Now let me make sure that the list is right. So I come through here, and the first thing it hits is that's showing you, see all the little dots there? It's showing you a scatter plot. Yep, that's the kind that I'm doing. Come down here, my information's in list 1 and list 2. So I think I just turned them on. So I'm going to do second, quit, and get out of that screen. And now I'm going to hit graph. Okay, so I can see 3 points. I can't see 4. There should be 4 points there. So what could I possibly do? So remember the zoom button, which was really nice. We played with it the other day. So I'm going to hit zoom. And this time I'm going to go all the way down past 7, 8. When you see zoom stat, hit enter. Look at that. It set the window so I can see as many points as I put in. I put in 4 points. Now I can see them. And if I look at my points, they almost look like they form a straight line. So I'm going to guess that that is a linear equation, that I could draw a linear equation through that. So let's see if we can come up with an equation. I'm going to hit the stat key again. I'm going to go over to calculate this time. And I'm going down to linear regression line, and I'm going to hit enter. Okay. If I go to the bottom of this, it says calculate. So when I'm sitting on top of calculator, I'm going to hit enter. And look at that. It just gave me an equation. So off to the side here, I'm going to write the equation. So it is y is equal to ax. A is my slope. And what is a? It's 1.5. And what if I round to the nearest place here? So I do 1.54. So I'm going to do 1.54x plus b. b is 6.75. All right, that's my equation. I'm going to try putting that equation in and see if it fits nicely on my data. So now I'm going to go to y is equal to, and I'm going to put my equation in. So my equation is 1.54x plus 6.75, and now I'm going to graph it right on top of the stat plots. That's not bad. It's a pretty close line. So the calculator came up with this pretty decent looking line that goes through most of my points. It's off by a little bit there. I'm going to go back a minute and pull up the handout that I just gave to everybody. So now, what was the relationship? The relationship that we saw in here was, I'm going to type it right in here, was y is equal to, we had y is equal to 1.54x plus 6.75. So that was our equation. But we want to know how strong a relationship it was. So, it looked like most of the points were close to the line, but I want to review with you correlation coefficients. So this was from Algebra 1, and it's been a while, but remember when we talked about a correlation coefficient, if all of the numbers on the scatter plot fell right on the line and they were perfect, then you would have a correlation coefficient of 1. So perfect is 1. If the line is going in the positive direction, it's a positive 1. If the line is going in the negative direction, then it would be negative 1. If the points are sort of close, but not all on top of it, then it would be a number close to 1. So it might be that this is 0.7, 0.8, 0.9 that would describe these points. And down here where it says it's very weak and the points don't look like they're following any lines, then it would be close to 0. So it might be 0.2, 0.3. So perfect is 1, and anything less than 1, all the way down to 0, shows a weak correlation. So how good is that correlation? Well, first of all, the slope is positive. So it's really close to a 1, a positive 1, I think, because most of my points were there. So hold on a minute, I'm going back to my calculator and we'll look. Okay, so let's look at when we calculated this. I'm going back over here and coming down to linear regression and hitting calculate. Can you see where the R is 0.99? That means my points are really close to that line, and it's a really good line. So what kind of relationship's going on there? A very strong relationship. So that's a pretty good line to describe that data. If on your calculator you don't see this R, I'm just going to take a minute and show you how to get to it. So if R doesn't show up, you're going to come down here and see what says catalog. You're going to do second, and you're going to hit the catalog button. So it's actually 0. And this is what's going to come up. So those are all the possible things your calculator can do. And you're going to scroll down. And it's all alphabetical. So you're going to scroll down to when you get to diagnostic. And you're going to be here where it says diagnostic on. And I'm going to hit enter. And now your calculator is looking at you and it's saying, do you really want me to turn on? And you say yes. And how do you say yes? You hit enter again. And now it's done. So now when you go back to stat and you go to calc, if you didn't see a regression coefficient before, now you should. So now you should see that R at the bottom here, and it will tell you how good your line is. Okay, so that's working with a regression coefficient and a regression line. Let's do the same thing for quadratics. So this is the data we're going to use. We're going to try and answer the following questions. So I'm going to ask you to go through the same steps we just did a minute ago. you're going to hit the stat key. You're going to put in where it says time in seconds. That's your list 1, 0, 1, 2, 3, 4. And then in list 2, you're going to put 0, 256, 480, 272. I'm going to stop here. I'm going to do it on my own, and you're going to do it on your own. We'll come back and talk. Okay, so this is what it should look like when you put your data in. So if you took a minute, just make sure that your data looks the same as mine. And now we're just going to calculate. So again, we're going to go to Stat. We're going to go to Calculate. And this time, instead of the equation of a line here, we're going to do a quadratic regression because in the problem, they told us that it's a quadratic situation. Okay, we're going to come down to Calculate. And there we go. There's our equation. Okay, so what is that equation going to look like when I write it down? Oh, it's right here. It is y is equal to, so what's A? A is negative 16. X squared plus 272 plus C is 0. Do I need to write the 0? No, I don't. Now I want to do a couple things. So that's my equation. I know what it is. I want to take a look at my data. So I'm going to graph it. Well, I have an old line in there. That must be the one from before. So let's get rid of that. So I'm clearing that. All right, let's go back and graph again. So that's my data. I don't see any of it because the scale is different. So let's hit zoom. We're going to come down to zoom stat and hit enter. There's my data. Now I can see it. It looks like a line. It doesn't look like a curve, does it? But let's see if this is going to work. So I'm going to try putting that equation in. So I'm going to go to y is equal to, and I'm going to put negative 16x squared plus 272. Oops, I'm missing the x. X. And I don't need the plus 0. And I'm going to graph that now. And it looks like it fits. So you can see that it is starting to curve. So the negative 16 is telling me that it's curving down. Okay, so let's see if we can answer some of the questions now that we have that graph. So this first step was find the quadratic model. We did. Use the model to estimate the height of the rocket after 1.5 seconds. Okay, so there's a couple of ways that we can do that. So we're looking for when the x value is 1.5. And looking at this thing here, it's sort of hard to tell what's going on. We can use this trace button right here that lets us trace along and see if we can figure out what's going on as x changes. And another thing we can do that's really nice is if we go here to second calc, which is right above trace. And if I want a particular value, see what it says value, I'm going to hit x. And it says when x is 1.5, I will find out what my matching y is. Well, y is 372. So it's saying after 1.5 seconds, the ball is going to be 372 feet in the air. Okay, well, I didn't mean balls, sorry. We're talking about rockets. And then the last question was, describe the Germanian range. So if we're looking at the graph, and let's go back and look at the graph. We can't see the whole graph. So let's see if we can do something about that. So here's where you're going to get really comfortable with playing with the window. So remember, standard window goes from 10 to 10, negative 10 to negative 10. Okay, so here, look at this window. It has a maximum of 973, but it's still not high enough. So why don't we make that maximum, I don't know, 1500. See what happens. Okay, I'm getting up there. I could probably see the top of the graph now, but I can't see very far in the x direction. So let's make the x bigger. So if the x is right now at 4.4, why don't we make that 10 and see what happens? Oh, now it goes up. Oh, still can't see it all, so let's make that x bigger. So let's make it 20.